Hello everyone, today we're going to apply what we learned in method of join and method of fiction to solve two problems and find internal forces in the trusses. So we have different forces. Some of the forces are external force like reaction or external force like this, and some forces are internal force. It means they are inside the member. So when we talk about analyzing the truss, we usually mean finding the internal forces. Okay, let's see what is the method of section and what is the step-by-step solving the problem. The first step is to find, usually sometimes most of the time we need to find reactions in the support. So for example, at A, we have two reactions, AX, AY, and for the roller, we have only one reaction. So the first step is finding reaction AX, AY, and FY. What is the next step? Sometimes, of course, we don't need to find all the reactions. So we need to be smart and think if we don't have to find all the reaction, just avoid that steps. The next step is find a good cut. Find a good cut. Where we can do or cut that is less time consuming to solve the truss. So here is a good cut. If we cut from here, for example, if we need to find the internal force that we had in previous lecture for these three forces, the good cut is the cut that is just involve all three members that we want to find internal force, and also the maximum unknown we have is three members. All right. So the next step after we find a good cut, the next step is decide which side decide which side to analyze. Which side is easier, left side or right side? Okay. The side that which is involved with less external flow is usually the best part. So this side is the best side to analyze. What else we can do after we find the best cut and decide which side we want to analyze is to draw free body diagram of the side we want to analyze. All right. So I'm going to draw the side that I'm going to analyze. So I have Fy, GH, force in GH, EH, and ED, right? So it's imaginary cut. So we have like this. Then I need to apply equilibrium equation. What equilibrium equation I can use to find these three unknowns? So if I get the moment about E, what happened? E, and this is point G. So after we did everything from this part, we need to decide how to find these internal forces. So if I get some of the moment about E, if you look at these forces here, both of them passes through E. So from here, I can find what is GH. So if I get the moment about E equals 0, I can find GH. After I found GH, okay, if I use sum of Fx equals 0, the only, or sum of Fy maybe first. I use sum of fy equals 0, the only fy component I have is this fy and also fy component of this. Of course, we have 40 kilonewton here. We shouldn't forget about this one. So that's all we have for fy direction. So from here, I can find the internal force in EH, right? We solved this problem in previous lecture. After we find this one, we can find the last member, which is ED, from sum of fx equals 0. So this is 1, this is 2 equation, and this is 3 equation to find 3 unknown. Oh, all right. So this is a step-by-step finding the method of action. First, if we need to find reaction, sometimes we don't have to find all the reaction, one is enough. Then find a good cut which is involved with the member that we want to find internal forces, and then cut it from that part and decide either right side or left side is a good part to analyze, and then draw free body diagram of that part and find internal forces. All right, let's solve an example and see how we can apply the method of Joule. In this example, determine the force in the member EF, so it's this one, EP is this one, KL, which is this one. It's Baltimore Bridge truss and state if the member are in tension or compression. Also indicate all zero force member. Alright, so for zero force member, you know, if you have non-collinear member, collinear member like ML and LK, and the third member, which is LE, it's non-collinear. The non-collinear one is zero force member. So then we need to decide which part is a good part to cut. So I decide to cut the truss from here. Why this cut is a good cut? Because first of all, it's involved with the member that we want to find internal force. The second one, I have 3 equations and 3 unknowns, so I'm able to solve. Then we need to decide which part is a good part to analyze. Maybe the right side is a good part to analyze. Before everything, we need to find reaction, as the first step is find reaction. When we consider finding the reaction, find the support reactions. The first step. It's we need to consider the whole free body diagram for the whole truss. So it's a free body diagram of the entire truss. When we want to find internal force, we need to cut. But when we want to find the support reaction, we should consider the entire truss. So I have 2 reactions here. It's AY, AX, because it's a hinge, and the other one is a roller. So I have IY. So I'm going to analyze this side, okay? So if I want to analyze this side of the truss, which is right side, I just need to find IY. So how I can find IY? Any idea? All right, I can find IY if I get the moment about A equals 0. Let's say counterclockwise is positive. So IY multiply the distance which is 16 feet, and it make counterclockwise moment, so it's positive. What else we have? We have 2 kilonewton, so it's 2 multiply the distance, so I'm working on this one. What is the distance? It's 12 meter, and it make counterclockwise moment, so it's negative, right? Then I have 3 kilonewton, the distance is 10 meter, and again make clockwise moment, it's negative. Then I have 5 kilonewton and the distance is 8 meter, and the last thing is 2 kilonewton multiply the distance, which is 4, equals 0. So solving this equation, I can solve for Iy. So Iy is 6.375 kilonewton. I got the positive number, so my assumption about reaction is correct. So the first step is just finding the reaction. Now the second step is to cut and analyze the side we want and find internal flow, internal forces. All right, let's go ahead, cut it from here. That is involved with the internal forces that we want to find, and then draw free body diagram. Okay. All right. So here is the free body diagram for the member I want. So I already found the reaction from previous equation for the entire truss. Now the unknown I have is this one, which is force in EF, force in EP, and force in LK. All right, so I need to decide which point is a good point to get the moment. All right, so what do you think? I usually use the point that, at least two forces go through that point, so I can get rid of those forces. How about K? Point K. If I get the moment about K, this force, which is LK, and also EP passing through K, so I can get rid of that, and the only forces that is remaining is FEF, right? So I can solve for this one. All right, maybe somebody else wants to get the moment about E. Again, it's a good point. Why? Because all these two forces passing through E, and they they don't have any moment, so I can solve for LK. All right, so both of them is correct, and we're going to use both of them. All right, let me write it down. So sum of the moment about K equals 0. Let's say counterclockwise is positive. So all I have is 3 kilonewton multiply 2 meter plus reaction, which is 6.375 multiply the distance from K, which is 4 meter, and FEF make clockwise moment. So this one make clockwise moment, it's negative. FEF multiply 4 meter equals 0. From solving this equation, I can find internal force in EF, which is 7.875. What does it mean? It means the direction I assume for internal force is correct, and I assume it's in tension, so I got the correct one. In this problem, if you look at the direction, you can see I assume some of them are in tension or compression. It's up to you. The direction, it doesn't matter, because at the end, if you get positive, it means your direction is correct. If you get negative, it means if you assume it's in tension, it's not in tension, it's in compression. All right, so I found one of the forces that I want. I still need to find two more internal forces. So let's use sum of the moment about E equals 0, and positive direction is the direction I want. So I have my reaction, which is 6.375, multiply the distance, which is 8. It make counterclockwise moment, it's positive. I have 2 kilonewton, multiply the distance, which is 4, make clockwise moment. Similarly for 3, and FLK, multiply the distance, which is 4 meter, equals 0. From this equation, I can solve for FLK, which is 9.25 kilonewton. Forget the unit here. And again, I assume KL is in compression, and my assumption was correct. Otherwise, if I got negative, it means it wasn't in compression, it was in tension. Now it's time to find the last one. What is the last one? Last one is force, internal force in ED. Where is ED? EP? It's this one, okay? We want to find this one. We already found this one and this one, so the only one that is missing is this one. Either we write sum of fx or sum of fy, we can find the next one. So I'm using sum of fy equals 0. Let's say up is positive. So I have my reaction, which is 6.375 minus 3 kilonewton minus 2 minus FEP. The angle is sine of 45 equals 0. And from here, I can solve for FED, right? It's 1.94 kilonewton. And since I got positive, it means the direction I assume it's correct. All right. So this is how we solve any trusses with the method of section. Now I'm going to solve another example with the method of section and join together. Because sometimes the number of unknown we have in a truss is more than 3, and the method of section is not enough to solve the trusses. So we need to use method of joint as well. Okay, let's see another example. So in this example, it says determine the internal force in the member IC, which is this one. It's IC, it's this one, and CG, which is this one, of the truss, and state if these members are in tension or compression. Also indicate all zero force member. All zero force member. All right. So from zero force member, you remember if we have two non-collinear member without any external force or support, they are zero force member. So AB and BC are zero force member. Similarly, for DC and DE, they are zero force member. Now we are going to find the internal force in this one. First of all, uh, if we want to solve this problem, we need to find the reaction. But let's see which cut is a good cut, and then from there we can think about how we can solve the problem. Actually, it's very hard to find the cut that cut both of them, because any cut we assume here, it's involved with more than 3 members. So for now, because this one is 0, maybe we can cut from here and then find IG, and then think about how we can find CG. All right. So I decide to cut the truss from here. Then we need to think about which side it's a better side to be analyzed. So this part, it means the left side is the better side. Why? Because I don't have this 6 kilonewton external load. So I only have two reactions here, AY, AX, and for the roller I only have EY. I decided to only solve the left side. AX, there is no force in the x direction, so this one is 0. I only need to find AY, right? How can I find AY? When we find the reaction, so step one is finding the reaction. Find the support reactions, right? Whenever we're finding supports reaction, we need to consider the entire truss. So how I can find AY? Maybe if I get the moment about E, it's easy to find AY, right? So stop the video and find AY. Alright, so sum of the moment about E equals 0, let's say counterclockwise is positive. AY multiply the distance. What is the distance? From E, it's 6 meter. Okay, so it's 6 meter, and it makes clockwise or counterclockwise moment. It makes clockwise moment. That's why it's negative. Then plus 6 kilonewton multiply the distance, which is 3. How about the direction? The direction make counterclockwise moment. That's why it's positive. Similarly, for the next force, which is 6, and the distance from E is 1.5 meter equals 0. From here, what is AY is 4.5 kilonewton. I got positive, so my direction is correct. All right, now I have the first step is find the support reaction. The next step is to cut and draw free body diagram for the part we want to analyze. All right. Let's go and draw free body diagram for the left side of the truss. All right. For here, I need to use some of the equilibrium equation. Usually, sum of the moment is the best one. Okay, can you tell me which point is a good point to get the moment? We want to find this force CG. Okay. If you look at these two forces, this one is 0. These two forces passing through point G, right? So if I get the if I get the moment about point G, both of these forces passing through G, they cannot make moment. This one is also 0, so I can find FIC very easily. So let's write sum of the moment, sum of the moment about G equals 0. Let's say counterclockwise is positive. So what I have is the reaction is 4.5, so it's 4.5 multiplied distance from G, which is 3 meters. How about the direction? It makes clockwise moment, so it's negative. Plus, I have a 6 kilonewton here at, let's see, what else I have? FIC. There is two components for this one. Let me change the color. So I have this component and this component for FIC, right? So if you look at, oh, I need the angle. So for the angle, you know this number, if it's 4, 3, 5, it's similar things here. It's 2, 1.5, and this one is 2.5. So I can use this as slope, right? All right, so it's FIC. I'm getting moment about G. So one of this component, the X component, doesn't have any moment. Let me change the color. So one of these passing through point G, it doesn't have any moment. The other one can make moment. All right. So FIC 3/5 and the distance is 4 equals 0. So from here I can find FIC, which is 5, 6 to 5, and I assume they are in compression. I got positive, so my assumption was correct. All right. So the next step is to find FCJ. What is FCJ? Because I want to find FCG. Okay. So if you look at the joint C, these forces are zero force member. This force and this force are zero force member. I already found this this member, which is CI. So whatever I have for CI, because of the symmetry, I get for CG. So I already know CG also is 5.625. So let me change the color. So this one is also is 5.625. Why? If I write sum of fx equals 0, I get FIC equals FCJ. Okay, so if you look at joint C, you can see the only things that I don't know is FCG. So the problem asked from CI that I already solved and CG. So from analyzing the joint C, so I use method of joint at point C. I can find this force. And also what else I need? I need sum of Fy equals 0. And from here, I can write 4 over 5, it's a slope, 5, 6 to 5, plus 4 over 5, 5, 6 to 5, minus FCG equals 0. Solving this equation, FCG equals 9, and it's in tension. And the unit is kilonewton, and for this one is also kilonewton. All right. Solve this problem by yourself again, so you get familiar with how to solve a truss with the method of section and method of join. Next Friday, you have a quiz from method of section. All right. So let's call it day and enjoy the rest of the day.